Electron beam deposition is a quite commonly used deposition process in both the semiconductor industry and for researchers. It has a high utilization of the deposited material. You can have quite high rates and also reasonably low. And you can deposit at a range of temperatures from room temperature all the way to several hundreds Celsius. It works by focusing an electron beam on the material you want to melt. This in turn melts the material, and evaporated particles are then deposited on the surroundings, mostly in a straight line from the surface normal of the melt. You can deposit many different metals and dielectrics. For instance, aluminium and silicon oxide. It's also possible to perform reactive deposition if you have species that are easily oxidized, for instance. Our workhorse is an Ångström EOVac system. It has one electron beam source and two sources for thermal resistive heating. A process quite similar to E-beam, only that it uses a resistive boat to heat and melt the material you want to deposit. We can use all three of these sources to co-deposit, or we can use only the electron beam to deposit up to 6 different materials without breaking vacuum. We can also do this at substrate temperatures from room temperature up to 500 Celsius. And we typically use deposition rates of half an angstrom a second up to 2 angstroms a second, although we can go both higher and lower. We also have an oxygen gas inlet for reactive deposition. We mainly use our system to deposit contacts, either Schottky or ohmic. We have also some experimenting with creating nickel oxide, a high band gap semiconductor.